All right, so let's go back up to our cloud computer. Where are we? Okay. Okay. Everybody's back up. We're going to edit again. We're going to edit once again our control file. Now, I'm going to, for some reason I don't entirely understand, it left me where I was when I left off. So if you hit your page up button, which on this, all right, hit your page up, go back up to that ICIC again. Everybody set? I'm going to go down to where the heck is my cursor? Ah, there it is. Okay. I'm going to go over to here to where it says uniform. I'm going to put the cursor on U. We're going to change this to binary. And everybody now understands that it has to be right justified and the Y of binary has to be under the last C of ICIC, okay? So I'm going to hit the Shift R, which is replace, space, and then we're going to go uppercase B-I-N-A-R-Y, binary. And once again, we see how that's aligned. Cassie, we got that? I see questioning eyes over there. We've got it. Okay. And then we hit the escape key to get out of that. All right, so here's what we're doing. We've run the model from a set of initial conditions. We've seen that we have some transients in our solution. If this were a real 10-year simulation of Chesapeake Bay, we couldn't use those first 2 or even 8 years because the effect of the initial conditions was still in there, and we want to get those out. So what we're going to do is we're going to go through this loop process. We're going to loop the model. And what we're going to do is we're going to run the model over again, but we're going to use the outputs from the first run. And those outputs are written in binary, because rather than have one number, one salinity that we imposed on everything, we've now got 30 values of salinity that were saved from the previous run. And rather than run one value for G2 carbon that was arbitrary and was in what's the word I want? Anyhow, in motion, transiting, we're going to have 10 G2 carbons that result from the previous run. But those are written in binary. So what we've done is we've gone into the control file and we've told the model, this time we want binary initial conditions. Go ahead.
Is this control file, this is for the non-point source load?
This control file it controls the entire model. So the beginning of the control file, we said things like how many cells are in our grid, how many years do we want to run. Then we get down to a place where we start describing parameters of our run. What kind of files do we have? We could turn the diagenesis model off. What state variables do we want to run? So we go through that. Then we get to a place of where are the files that specify our inputs and outputs. So it's the control of everything. The non-point source is one of the files that we're going to name.
Okay. I just thought since it had the NPT.
Oh, NPT is input.
Oh, that's for input. Okay.
NPS, non-point source.
Okay. Right.
Okay. So I'm going to go page down. I'm going to page down. Now here, I've got that ICI. And this is the, right now, this is the uniform set of initial conditions that we used to run our first round. So what I'm going to do is I'm going to put my cursor right there, big R, replace. And let's give it, this is the input initial conditions. We're going to give it the file that we wrote out in our previous model run. So we're going to type outputs / WQM _ ICO.opt. And I'm going to space a little bit to get rid of the residual. I hope that was the name of it. If it isn't, we're going to find out quickly. We running out of tape? Running out of time? Uh-oh. Okay, well, we'll do our best, you know. Okay, so we've given it a new initial condition input file. One more thing I'm going to do, just for good practice. Okay, the initial conditions output file. Now, I can run this model just like it is right now. But what it's going to do is the initial conditions that I wrote for my previous run are going to get destroyed. They're going to be written over with the initial conditions from this run. Maybe we want to do that, maybe we don't. I think it's not good practice, because if you ever want to use them again, they're gone. So you see I've got the cursor on the T for output. I'm going to type A. Really? A is append. There it says insert. But in any event, I'm going to type A. I'm just going to type a 2. This is the second set of initial conditions. Escape. Everybody with me? Okay, so we remember colon, right quit. So now we've altered the control file and we have saved it. In the interest of time, everybody's here. In the interest of time, let's see what happens if we just go WQM. Is it going to blow up, Richard?
If everyone do the same time, is a risk. If everyone does the same time, there's a risk to crash the computer.
Well, it's a supercomputer.
No, it's a super, but it's very little supercomputer.
Okay, how do we want to do this? Okay.
Use the S-run. I think now it's quicker.
Use S-run?
Yeah.
Okay. Richard says to go S-run, so let's try it.
John did something and it's supposed to be, but it's still only 4 edges. Yeah, just do that.
Okay, so we'll wait, you know, as long as it takes to get this finished.
It's running, yeah. And some students 4 and 5 already did it.
What's that?
There are 2 students did it before you. So.
Do we want to go to lunch and pick this up after lunch, or do we want to see this through? Who wants to go to lunch? Nobody. Who wants to see this through? Done. Message. So, just as we did before, if we do an ls minus L, what you'll see is we now have a new snapshot file. The most recent file we created, there's a new snapshot file. So we did write over our previous one, but we'll live with that. So let's do our, we're going to up to our read snap file, just as we did before. We'll hit enter. So let's look at one more time salinity. So we're going to type 2 for salinity. What sediment variable? Let's look at our G1 carbon. So we're going to type 5. And away we go. Everybody set?
Was that the read snapshot file?
Excuse me?
You just executed a read snapshot
Yeah.
file?
And we typed in 2 for salinity and 5 for G1 carbon. Okay, so now hopefully we've created our set output and WQ output, and just as we did previously, let's rename these so that we don't write over them. And what we'll do now is we'll call it salt underscore round 2. So this is now the second model run, so we're going to call it salt round 2. Away we go, and we'll do the same thing. Whoops, where'd that go? Okay, the sediment output we're going to call G1 carbon underscore round 2. So now we've got a carbon and a salinity from the second round. As we did previously, let's run that again, the read snap file. This time, let's do dissolved oxygen, which is 27. And we'll do the G2 carbon, which is 7. So we want to do 27 and 7. Everybody ready?
What was the second? How did you call the second file? G1. Oh, G1 was?
G1 carbon underscore round 2. And then we're going to read again our snapshot file, and we're going to look for variables 27 and 7. Okay. And just as we did previously, we're going to rename those. Instead of salt, we're going to have DO. And for the sediment, instead of G1, we're going to have G2. Last one coming up, I promise.
So for G1, you used variable 5. For G1, you used variable 5.
Oh, shoot.
It's supposed to be 3.
4. Even worse. Okay, well, we can run that. We can run that again. I mean, I screwed up. I used variable 5. My notes were box 5. So I'm going to do it again now. Why didn't anybody stop me? All right, so I think we've done I hope we've done the dissolved oxygen and the G2 correctly. We need to go back and redo the G1. It's not a crime. It's not that hard.
Variable 3.
What's that?
It's number 3. G1.
Okay. No, in the sediments, G1 is variable 4. Let's try it again. We'll read our snapshot file again. I think we did salt, right, which is number 2.
Yes.
And for sediment, G1 carbon is number 4. Of this, I'm certain now.
Can we just have sediment variable and not run the other one?
No.
Okay.
This is a real simple hacked processor, you know what I mean. You can always plot anything you want for the water quality and not look at it, but it's going to always ask you that question. So, but it's a simple Fortran program. You could probably fix that, you know. All right, so we've got 2 for the water column, which is salinity, and 4 for the G2 carbon. I think we did the salt correctly previously, so all we have to do is move the set output to G1. If I'm going too fast, I'll stop. Everybody okay? And John, what sediment variable are we going to plot next? He's got it. Okay. So let's run that. Read snap file one more time. In the water column, what have we done? We've done dissolved oxygen. We've done salt. Just because we got to type something in, we'll type 1 for temperature. We probably won't look at it, but just because we got to type something in. And for sediment, G3 is number 10.
Can we pause for a second?
What's that?